Good afternoon, guys. How are you? I hope you're doing well. Here is our final revision of calculus. Mr. Ibrahim Hajaj is talking with you. And Bismillah, let's get started. Let's revise, guys, here and solve some important questions that's related with our requirements we need to study for the final exam. So, Bismillah, let's get started first with this question. And the question is asking you to find here, evaluate each of the following limits if exists. The limit as x approaches 0 of sine 4x over 3x. Simply, I would like to remind you guys of this formula we have said before, which is the limit as x approaches 0 for sine ax over bx is equal to a over b. So your answer here is simply going to be 4 over 3. And x short approaches to 0. This only for trig functions, sine, cosine, tan. Next question, evaluate each of the following limits if exists. The limit as x approaches infinity of sine pi x plus 2 over 2x plus 1. First of all, we have a property of limits that the limit as x approaches 0 of sine function, we can write it as sine, and then the limit as x approaches infinity of this function, which is pi x plus 2, and this all over what? 2x plus 1. Okay? Yes, 2x plus 1. And guys, we said before here we have 3 cases. Let's recall this quickly, guys. We have 3 cases as x approaches positive or negative infinity. And it's a quick way to find your value of the limit quickly. When you compare the degrees, when degree of the numerator is greater than the degree of what? The denominator. What should you do? Yes, when the degree of the numerator is greater than the degree of the denominator, you just take the term that including the leading coefficient up here. For example, x, if it's 4x to the power of 3, and this all over 2x squared, so we're gonna take only what? Here, these 2 terms only, plus something here, plus minus something here. We take only the terms in the beginning or the leading coefficient terms. And then we simply find substituting the positive or negative infinity according to the question. The next case, when we have the degree of the numerator is the same as the degree of the denominator, when degree of the numerator is equal to the degree of the denominator, in this case, we just take the leading coefficient, like 4x over 3x. In this case, your answer will be 4 over 3. We just take the leading coefficient up over the leading coefficient down. But if the degree of the numerator is smaller than the degree of the denominator, for example, in the numerator we have quadratic function, and in the denominator we have power what? 1 linear, like 3x, it's linear, and in the denominator it's a quadratic, 3x over 4x squared plus something. So what should we do here? We have to take only the answer will be 0. Yes, the answer will be 0. So simply here, if we note, guys, do we have the first or second or third case? I think that we have here what? The second case, when the 2 degrees are equal. The degree of the numerator is linear, is 1, and the degree of the denominator is 1. So simply and directly you have to write that your answer will be sine. And the limit as x approaches, here, this whole function, yes, is equal to what? As x approaches infinity is equal to pi over 2. Is equal to pi over 2. Why? Because in the second case we said when degrees are equal, so what should we do, guys? We have to take only the leading coefficient of the numerator divided by the leading coefficient of the denominator, pi over 2. And then what's sine pi over 2? Sine 90 is equal to, yes, excellent, is equal to 1. Is equal to what? To 1. Okay. Next question, find the horizontal asymptotes of the graph of the function f of x equals the cubic root of 2x cubed minus 9 over x. In this kind of questions, the question is asking you guys to find here the horizontal asymptotes. So simply you have to take the limit as x approaches positive infinity or negative infinity as you like for the function f of x. So the limit as x approaches infinity of the cubic root of 2x cubed minus 9 and this all over x. Yes, the degree of the numerator here is what? It's 3 and the degree down is x. You know, do you remember guys when we said we have to divide by x? Right? So simply here the answer will be dividing down by x, and up here we have to divide by x. But when you divide any cubic root by x, you know you can put this x inside the square root. You can insert this x inside the cubic root as x cubed. So it's like this, the cubic root of 2x cubed over x cubed minus 9 over x cubed, and this all over x, and here the limit as x approaches positive infinity. So the limit as x approaches positive infinity of x over x is 1 in the denominator. In the numerator, the cubic root of 2x cubed over x cubed is 2 minus 9 over x cubed. Yes, do you know that you can take the limit for 9 over x cubed, which is 0? Yeah, it's 0. 9 over infinity, it's what? It's 0. So you will find that the limit as x approaches infinity for 9 over x cubed is 0, and the limit as x approaches for any constant here is 2 is the same, and the cubic root of 2 stay the same. Over what? Over 1. So our answer here will be the cubic root of 2 over 1, and then leave it as cubic root of 2, or you can find it as a decimal around your answer to the nearest hundredths, if possible. Okay. Yes. Next. Yes. Next question. Okay, guys. The next question, what is the limit as x approaches negative infinity of x cubed plus x minus 8 over 2x cubed plus 3x minus 1? Okay, in this question, we will simply, guys, compare the degrees of the numerator and the denominator, and since they are equal, so simply we have to take the leading coefficient here over the leading coefficient in the denominator down. So the leading coefficient up is 1 and the leading coefficient down is 2, simply. Next question, let f of x is equal to 3x minus 1 over x cubed minus 8. Now, letter A, we would like to find the vertical asymptote or asymptotes of f, and letter B, find the horizontal asymptotes of f. So in letter A, yes, to find the vertical asymptote of this function, we have to let the denominator is equal to 0. So x cubed minus 8 is equal to 0. How to factorize here? Or you can take the 8 to the other side. It will be positive here, and then take the cubic root for each side. So x is equal to what? 2. Then you have to find the limit as x approaches positive infinity. Okay, you have to find here, guys, the limit as x approaches positive infinity. Okay, guys, so we have to take here the limit as x approaches 2 from the right side, and also you have to find the limit as x approaches 2 from the left side of this function. Okay, 3 like this, 3 into 2 plus minus 1, and this all over 2 from the right side, like 2.001 minus 8. Okay, like 3 times 2.001, any value to the right of 2, 3 times 2.001 equal minus 1. equals 5.00. Okay, 3. Yes, it's 5.003, and this over what? 2 plus, which 2.00, 1, the cubed, should be cubed, yeah, to the power of 3. Yeah, it gives 8.0, 1 like this, minus 8. Yeah, which is 0 point. So it's 5.003. You can do it quickly in your calculator. 0.0112. So dividing 5.003 divided by 0.012. Yes, the answer will be positive infinity. And when you do the same thing, guys, when it's here, 2 from the left side, like 1.999. So 3 into 1.999 minus 1, and this all over 2 minus, or 1.99. Let's do it here. 1.99. Yes, it's 1.999 to the power of 3 minus 8. The answer also will be positive in infinity. So we have a vertical asymptote at x equal 2. We have a vertical asymptote at x equals what? 2. And we make sure, and it's what? Positive, positive. Like this, yani we have a vertical asymptote at what? At 2. And here at 2, there is a vertical asymptote, and it's positive, positive, like this, from the right and left of 2. To answer letter B, let's say here, find the horizontal asymptote. Find what, guys? The horizontal asymptotes, or asymptote of this function. So to find the horizontal asymptotes, we have to take the limit as x approaches positive infinity of 3x minus 1 over x cubed minus 8. And now it's the limit as x approaches positive infinity. And since here the degree of the numerator, no need to write it again. So let's erase it here. And since the degree up is less than the degree down, so it's a 0. So your horizontal asymptote is y is equal to 0. The horizontal asymptote is what? Is y is equal to 0. Since what? The value of this limit as x approaches infinity or negative infinity of this function gives us here 0. So y equals 0 is the equation of the horizontal asymptote. And it's what? On the x-axis. Next question, find the derivative dy over dx of each of the following. I tried here, guys, to collect all kind of functions, this question. Like the first one, for example, we're gonna find dy over dx directly and in the regular way. Dy over dx, or y prime, as you like to write, it's 5x to the power of 4 plus 3x squared, and then here plus, drop down the exponent and subtract 1 from the exponent, plus 2x. That's it. But in the second kind of questions, find the dy over dx of x squared plus x to the power of 25. To find the y prime here, we have to drop down the 25 first. This is the chain rule, and then write again the same parentheses. Okay? Reduce the power 25 by 1, so it's gonna be 24, multiplied by here, multiplied by what? The derivative of the inner function, which is 2x plus 1. That's it. So drop down the exponent, subtract 1 from the exponent here, subtract 1 will be 24, and then don't forget, guys, to find the derivative of the inner function, which is 2x plus 1. Okay? Okay, next. Find also dy over dx of the function y equals the sine x over x plus 1. Directly, as we practiced before in our revision time, we said when we have a fraction, we have to use what? We have to use quotient. We have to use quotient rule. The quotient rule. We will let u, no, not like this. We will let u equals, we will let u is equal to the numerator, which is sine x, and the derivative u prime, which is cosine x. And we will let v, which is the denominator, x plus 1, and v prime, which is the derivative of x plus 1, which is 1. And then if you remember, guys, here the quotient rule states that the y prime now, or dy over dx, is equal to u prime v minus v prime u, and this all over v squared, which is equal to, make a fraction, u prime v minus v prime u. So simply we can write it as cosine x times x plus 1, or we can write it x plus 1 cosine x, the same, then minus the v prime, which is 1 times the u, which is sine x, and this all over v squared. V here is x plus 1. So we're gonna square it. It will be x plus 1 all squared. And then leave your answer in this form, no problem. It's gonna be correct. Next question. Next question, find the derivative dy over dx of the following function. So I would like you guys to pay attention to this question, because in this question we have to use what? Chain rule. So y prime, it's easier, is the same as dy over dx. Y prime is equal to, listen carefully. First of all, we will write 2 cosine x squared. Okay? Multiplied by the derivative of cosine, which is negative sine, the same angle, x squared. Okay, and then multiply by the derivative of x squared, which is 2x. And then plus here, 10 pi over 3. What's the derivative of 10? The derivative of 10 is secant squared, same angle, okay? Pi over 3, secant squared, pi over 3. Okay, guys. I think it's clear till now. Next question. You can only here, guys, simplify more. You can do one more step to clarify your answer, or just multiply here 2x by 2. So if we multiply, gonna give us what? Gonna give us negative 4x, because we already also have negative here. So it's negative 4 cosine x squared sine x squared plus secant squared pi over what? Pi over 3. Okay. Next question. Find the derivative of this function tan inverse of 2x. So y prime here is equal to, what's the derivative of tan inverse of x? Let's write it here as a rule. What's the derivative of tan inverse? D over dx of tan inverse of u, such that u is any function like 2x, like cosine, like sine, like 4x squared, any function. It's 1 over 1 plus u squared times du over dx, times du over dx. So simply here, gonna be 1 over 1 plus, here is u, this all u. So when I square it, it's gonna be 4x squared multiplied by the derivative of u to the respect of x, with respect to x, which is 2. Okay, so simply on the final answer, we can write it here as y prime, or some of you prefer to write it as dy over dx is equal to, yes, 2 over 1 plus 4x squared. And this is your final what? Final answer. This is your final answer. Oh, this is the derivative of this function, tan inverse of 2x. Next question, find the derivative also of, find the derivative of, find dy over dx of x squared plus y squared is equal to sine xy. So easy, and when you find a question like this or a function like this, we cannot solve it here explicitly, so we should solve it what? Implicitly. Implicitly. And as you know, guys, how to differentiate implicitly? Easy. Let's do it together. First of all, we will find the derivative of x squared, which is 2x, plus the derivative of y squared is 2y, y prime, equals the derivative of sine xy. The derivative of sine first, and then the derivative of xy. And pay attention that the derivative of xy is a product rule here, because x is multiplied by y, so we have to use our product rule, u prime v plus v prime u. So first First, find the derivative of sine, which is cosine xy, and open bracket. You can do it easily and quickly, and you can do it at the right here. What u is what? The first x, and its derivative u prime is 1, and v, as usual, v is what? Y, and the v prime here is y prime. So we will write here u prime v plus v prime u, so it's 1 times y, which is y plus y prime times x, or x y prime. Next step is only to combine here all terms including y prime to isolate it and write it alone on one side. So simply I will multiply first here using the distributive property cosine xy by first and by second. Okay, so we have 2x plus 2y y prime is equal to, multiplying here, this is equal. Okay, multiplying cosine xy by first gives y cosine xy. And multiplying cosine xy by the second gonna give us x y prime cosine xy. Then, where's the terms including y prime? Yes, here's it, and here's another term. So let's combine them only alone on one side, yeah. Bring it here, so, or bring this side to, yes, and bring this side here. So we have 2x minus y cosine xy is equal to xy prime cosine xy, okay, minus 2y y prime. 2y y what? Y prime. Then, as you see, guys, here we have what? We have y prime, y prime. So let's take it as a greatest common factor on the right-hand side. So the left-hand side stay the same, 2xy cosine xy, and the right-hand side we're gonna take what? Y prime. And we still have here x cosine xy minus 2y. I know that we did a lot of questions in the same way. The final step only, I'm gonna complete it here. Okay, final step is to write y prime alone on one side, ensure by dividing each side by x cosine xy minus 2y. So the final answer is 2x minus y cosine xy, and this all over what? X cosine xy minus 2y, and this is your final answer. Thanks. Leave it like this, it's correct. Or pick your correct choice. It's gonna be like this one. No more simplification. Next question. Yes. In this question, guys, I would like you to pay attention, concentrate on this kind of question until that the function f of x equal x squared minus 4x plus 5 satisfies the conditions of the mean value theorem on the interval 0, 2. Then find the number c that satisfies the conditions of the theorem. So, simply, we would like first to start here by finding the value of f0 and f2. And you know how to do it by substituting 0 in the function, gonna give us up here 5, and substituting 2 in the original function f of x gives here 4 minus 8, okay, gives 4 minus 8, then plus 5, which is negative 4 plus 5, which is 1. So when they are not equal, we're gonna use here the mean value theorem to find a value of c that is between 0 and 2, and it has what? Same slope as the slope of the secant line. So f of 0 does not equal to f of 2. So in this case, we have to use the mean value what theorem, MVT. Yes. So in the MVT, what should we do, guys? What's the steps? We have to find the f prime of c equals f of b minus f of a, and this all over b minus a. So let's find first the derivative of a function and substituting c for every x. I know when finding the derivative gonna give us 2x, but we are finding here for c, so it's a 2c minus 4c, minus 4 only, sorry, equals f of b, f of 2, because b here is what? Is 2, and the a is 0. So f of 2, which is 1, minus f of a, which is f of 0. F of 0 is 5, and this all over 2 minus 0. Yes, 2 minus 0. And the next step, we will write 2c minus 4 is equal to 1 minus 5 is negative 4, negative 4 over 2. Negative 4 over 2 gives what here, guys? Gives negative 2. Okay, and then 2c is equal to negative, yes, 2 plus 4, which is 2. Do it quickly, and here c is equal to what? Is equal to 1. So there is a value, and yes, 1 is between 0 and 2. Yes, 1 is belong to 0 and 2, this interval up here. So there is a number c that satisfies the conditions of the mean value theorem. Okay. And remember, guys, that in the Rolle's theorem, in the first step here, you will find that f of the beginning of the interval is equal to f of the ending of this interval, and then you should only find the critical number by letting the f prime of x equal 0 and find the value of c that is between a and b, such that f prime of 0 equal f prime of x equals 0, or f prime of c equals 0. Yes, next question. Let f of x equal x squared. Find the absolute extrema of the function f on the closed interval 3 and 5. To find the absolute extrema, to find here, guys, the absolute extrema, yes, of any function, we have to follow these steps. So the first step is to find what? Yes, we will write 3 conditions here. The first of all, we have to find f prime. What is f prime of the function? Which is 2x. It's so easy. Yeah, the domain of the function is already numbered, so it's no problem here. So the function is continuous and differentiable, and we have to find the critical numbers. The critical numbers, we let the first derivative equal 0, and now x equals 0. Okay, next step is to find what, guys? To find, let's check if here 0 is a critical or not by testing some points and substituting an f prime. Okay, substituting a -1 gives a negative, and substituting positive value gives positive. So it's what here? It's decreasing and then increasing. So 0 is a critical number, and we now have to find f of. Take care, guys. We are substituting in the original function f of 0, and we have to substitute f of 3, and we have to substitute f of what? Of 5. F of 5, but here 0 doesn't belong to this interval, so no need to do it because 0 is not between 3 and 5. Okay, so we will find only f of 3 and f of 5. F of 3, substitute 3 gives what? 9, and substituting 5 gives 25. So this function, we will write at the finally that f has an absolute only maximum. It has only absolute maximum at x is equal to 5 of a value of 25. Okay, that's it. And no absolute minimum. Okay, next question. Find the vertical asymptotes of this function. To find the vertical asymptote here, I think that we did a question like this before in this revision video. So let's do it again. To find the vertical asymptote, we have to find what? We have to let the denominator only equal to 0, and simply all of us know that it's gonna be what? Positive or negative what? 3. It's going to be positive or negative 3. Okay. Okay, so let's continue here, guys, by finding what the limit as x approaches. We will study first at x equals -3, and we will say when it's a -3 from the right side of this function, which is x squared over x squared minus 9. Over x squared minus 9. Yeah, how to do it, guys? You know, -3 positive gonna give us 9, and when we have -3, from the right side minus 9, there's going to be here 9 over sure a positive number, a positive value. Well, a 0 gives about 0, which is 0 minus 0 from the left side, which is negative infinity. Okay, and when you find the limit as x approaches negative 3 from the left side, this all at what? At x equals negative 3. We have to do the same thing with x equals 3. Gives also 9 over negative 3 from the left squared from the left side, minus 9, which is gives here a positive value, which is 9 over what? 0 from the right side. Right? Which is here equal to positive infinity. Yes, so vertical asymptote at x equals negative 3, and it will be like this. Here's negative 3, and there is a vertical asymptote. One of them from the right side of negative 3 approaches negative infinity, and the other one approaches negative 3 from the left side, approaches positive infinity. We have to do this also when x is 3. When x is 3, we have to find the limit as x approaches 3 from the right side of this function. Substituting directly, gonna give us 9 over 3 plus squared minus 9, which is positive over 0 plus, which is positive infinity. Positive value, positive 9 or any value, positive, over 0 from the right side, gonna give us positive infinity. And 0 plus means a 0.0000 number. So when you divide 9 by 0.0001, for example, gonna give us a very, very large number, which is approaches infinity. And the more you add zeros to 0.001, the more you got a very huge number. So the limit, which is infinity. The limit as x approaches 3 from the left side of 9 over 3 from the left side all squared minus 9 equals a positive value like 9 over 0 from the left side. 0 from the left side, because 3 from the left side like 2.999 squared minus 9 gives a value negative 0 point something, which is negative infinity. So here we have a vertical asymptote also at 3. One of them is from the right of 3, like 3.000. It's positive infinity. And the other from the left side of what? 3, it's positive infinity. So we have two vertical asymptotes at positive or negative 3. Next question. The function f of x equals x4 minus 4x3 plus 10. Find the following, if any. Pay attention, guys. This important question. The critical numbers. All of you know how to find the critical numbers by using or finding f prime of x, which is 4x cubed minus 12x, right? And then take here 4x cubed minus 12x and equate it to 0. Step 2 is to take 4x common factor. So we have x squared now minus 3 equals 0. So either either x is 0 or x is equal to positive or negative radical 3. Okay? Okay. But you should taste here these points. And you should see, we will do it in the next question. And we will check if 0 and positive and the negative radical 3 are critical numbers or not. ممكن one of them, ممكن 2 of them. Okay. Letter B is related with the same function and is asking now find the interval or intervals on which f is increasing and decreasing. And this depends on the critical numbers we did in letter A. In letter A, I think that we said and we have either x is 0 or x is equal to positive radical 3 or x is equal to negative radical 3. So to now or state the intervals in which a function f is increasing or decreasing, we have to draw this number line and we put here negative radical 3 and here 0 and here positive radical 3. And then let's test some points and pay attention, guys, that we are substituting in f prime. So I have to write the f prime here. What's the f prime from the previous slide? It's 4x cubed minus 12x. It's 4x cubed minus 12x. Substituting, for example, any value less than negative 1.7 because negative radical 3 is exactly negative 1.7 something, one like this. So substitute negative 2 in this function here. When substituting a negative 2 in the function gives negative 8 to negative 32. Okay. طيب negative 32. Yes, let me to do it. Negative 32, and here 12 times negative 2, which is positive 24. So, yes, gives a negative 8. So it's a negative, and here this part is negative. Any value between negative radical 3 and 0, as we see here, guys, negative radical 3 is negative 1.71. So the value that lies between 0 and negative radical 3, like negative 1, on substituting here, gonna give us negative 4 plus 12, which is positive. So gonna give us here a positive value. Yes, let's return back here and check here for between 0 and radical 3. Between 0 and radical 3, like 1, and substituting 1 gives 4 minus 12, which is negative. It's so easy. And any value greater than 1.71 and greater than radical 3, like 2, gives here positive. So now we are sure that all of them are critical numbers, 0 and radical 3 and the negative radical 3. Right? Why? Because if a prime changes its sign from negative to positive and from positive to negative at these points. Okay, so as you see here, guys, here it's decreasing, and here it's increasing, and here it's decreasing, and here it's increasing. So we have to write that if the function f, yes, the function f has, yes, let's write directly. The function f is increasing, f is increasing on the intervals from what to what? Yes, from negative radical 3 to 0, union from what? Radical 3 to positive infinity. Okay, and we have to write that f is decreasing function on the interval from what to what? From negative infinity to negative radical 3, union decreasing again at between 0 and positive radical 3. Okay, so here the full answer of this question. Next question, by using the same function, we're gonna find here the local extrema of f. The local extrema of this function, depends on also the first derivative test and the critical numbers. So we said that negative radical 3 and 0 and positive radical 3. So, and we said also that it's here negative, and then what? And here it's positive, and then negative, and then what? Positive. This all from the previous steps you did in letter A and B. And you can use it here for finding the local extreme. The local what? The local extreme. So, since here the function is decreasing and then increasing and then decreasing and then increasing, so you will note that if a prime changes its sign from negative to positive, so if it has a local minimum at negative 3, so if it has local minimum at x equals negative radical 3, okay, and also it has a local minimum at positive radical 3, and x equal positive radical 3, it has a local minimum. Only if it has local maximum, a local maximum at x equals what? 0. And then you should find the value of each one of them. How to do it? We should find the f of radical 3, and you should find the f of negative radical 3, and you should find f of 0 by substituting in the original function. Pay attention, I don't have a calculator here, so I'm gonna leave this for you. Letter D, find the interval or intervals in which f is concave upward or concave downward, concavity. To study the concavity of a function, we have to depend on the second derivative. Okay, so the first derivative, we said it's 4x cubed minus 12x squared, right? Minus 12x squared. Yes, let's move back. Yes. Okay, this question to find the intervals in which f is concave upward or downward. I noticed that here that we have a mistake here. So I'm gonna do only this power 2 from the beginning. Okay. Okay. Okay, but if we do it 2, will not give this value, so leave it the same 3, and we have to do this all again. Since I make a mistake here in dropping down the exponent, I do it as, yes, I forget to do it. So let's do this question again, guys. The function f of x equal x4 minus 4x cubed plus 10. Okay, so when we found the first derivative, it's 4x cubed minus 12x power 2. And this is my mistake, I forgot this 2, and this all, my answer was not correct. So let's find again the critical numbers. So 4x cubed minus 12x squared is equal to 0. Okay, and then we're gonna take what? 4x squared, the common factor, and now we have x minus what? 3 equal to 0. Okay, yes. X what? Squared, common factor. So we have x minus 3 is equal to 0. Okay, minus 3 what here, guys? Minus 3 equal to 0. So either 4x squared is equal to 0, okay, or x minus 3 is equal to 0, and here x is equal to 0, and here x is equal to what? To 3. X is equal to 3. And let's hear, these are the critical numbers. The critical numbers. Okay, in the next question, we're gonna change everything again also. We're gonna change everything here. So find the interval or intervals in which f is increasing, decreasing. It depends on letter A. It depends on what? On letter A, which is we have x equals to 0 and x is equal to 3 are two critical numbers. So draw your number line, put here 0 and here 3, and test some points less than 0 and between 0, 3 and greater than 3. Less than 0 like -1, and substitute in f prime. F prime was what? F prime was 4x cubed minus 12x squared. 4x cubed minus 12x squared. This two that make a problem. Okay, so substituting -1 gives a -4 minus, yes, 12, which is negative. Substituting any value between 0 and 3 like 1 gives a 4 minus 12, which is negative, right? And here substituting any value greater than 3 like what? Like 4. Yes, so gonna give us a positive. Sure, gives a positive. So 0 is not a critical because f prime doesn't change its what? Sign, and only 3 are critical numbers. Okay, so we have to move back to this question and write that only the 3, the critical number. What's the reason? Because here the sign of f prime doesn't change at 0, negative, negative. So write here the intervals in which f is increasing and decreasing. We just write f is decreasing and here increasing. So f is decreasing from -infinity to 3, and f is increasing from what? From 3 to positive infinity. Next question, the local max also and the local minimum. We have to cancel this all and we have to repeat the answer again. Because the first derivative here is equal to 4x cubed minus 12x squared. This two I forgot it and make a big problem. So, and we said that we have two critical numbers, either one critical number now, which is a 3. So we said here it's negative and now it's positive. And we said that the function here is decreasing and then increasing. So we write only that f has local minimum, local minimum at x equals 3. And f of 3 is equal to 3 to the power of 4 minus 4 into 3 to the power of 3 plus 10, and then do it in the calculator. I'm going to leave this for you to do it. I don't have a calculator. Next question, the one who let me to know that there is a mistake in the previous two questions. In for a second derivative, to find the concavity, concave up and concave down. Yes, to find the concavity of this function, I'm going to find the f prime first, which is 4x cubed minus 12x squared, and then f double prime, which is 12x squared minus 24x, and then find your inflection points where the second derivative is equal to 0. I'm going to take 12x common factor. We have now x minus 2. Sorry, x minus 2 is equal to 0. So either x equals 0 or x is equal to 2 inflection points. Let us to check if they are inflection or not. We will know this when we draw the number line and we put here 0 and here what? 2, and then test some points. Let's test here -1 and substitute in f double prime. F double prime, it's equal to 12x squared minus 24x. Substituting a -1 here gives 12 plus 24, which is positive. Okay, and substituting here any value between 0 and 2 like 1. So we have 12 minus 24, which is negative. And substituting here any value greater than 2, like 3 squared, it's 9 times 12, 108, minus 24 times 3, which is 72. So still positive. So both of them are inflection numbers, 0 and 2. And now we should find what? The function here is concave up, and here it's concave down, and here it's concave up. So simply write that f is concave up on the intervals from -infinity to 0, union from 2 to positive infinity. And f is concave down on the interval from 0 to 2 only. Okay, so I hope to forgive me, guys, for this mistake, but you have also to take care. Okay, I hope you're doing well, guys, in your test, inshallah, and study well. And this all kind of questions you can face. And thank you, and see you, inshallah, later. Assalamu alaikum. And keep safe. Assalamu alaikum.